So I'd like to welcome on stage Holger and the Elektrobit Truppe.
Yeah, Paulina, thanks a lot. So my name is Holger Dormann, and with me is Kaloyan Rusev. Hi. We are both from Elektrobit, and we are very happy to present you Eclipse Ankaios, the new project in Eclipse. So, okay, that's not working. Okay, no problem. We take that one here. So in the talk before, we've heard that for the software-defined vehicle, we cannot just take IT technologies and we have to see how it works in automotive, and that's exactly true. And also for our project, what we did is that we analyzed what existing technologies exist, especially in the area of containerized applications. So containerized applications in general are a very interesting topic also for the automotive industry. You have advantages like increased portability, increased security, and also you can develop your containerized applications beforehand in the cloud, test them there. So these are all good things. And there are a lot of technologies in the cloud native world. And what we did is actually that we analyzed how those fits. But what we found out is that existing tools like Kubernetes cannot be used for automotive HPCs. They're designed for huge distributed data centers. And also there's eventual consistency, which is important for when you have a lot of nodes, when you have hundreds of nodes, when you have sharded databases. But in the automotive world, you don't have that. But instead, real-time and safety requirements exists. And also the programming languages that are used in the cloud-native world, which like programming languages Go with garbage collection, also the development process are completely different. And also performance and resource usage. So we've analyzed distributions of Kubernetes like K3s, and we found out that they need about 400 megabytes of memory and 20% of the CPU core just in idle mode, which is quite a lot even on today's automotive platforms. And also a lot of the functionality that exists isn't actually required in automotive. It's a huge code base, Kubernetes, and that's why we said, well, we need something different. And we started with Eclipse Ankaios. And it's developed from ground up for automotive HPCs. We developed it in Rust, and programming language Rust, which is used in a lot of Eclipse projects now. And we have a talk later on today also about functional safety in that area. And Ankaios is actually a slim but very powerful solution from our point of view to manage containerized applications on automotive HPCs. We support various runtimes because we found out there's not the one runtime that fits all. So there are OCI containers, which can be managed by Podman, for example, which we currently support. But there are also other things like native applications or maybe WebAssembly wants to be used on North Star containers, whatever. So Ankaios can support the different runtimes, and yeah. And also we support requirement tracing. It's not very common in open source projects these days, but it's required in the automotive world when you work like in automotive spice processes. We use OpenFastTrace for requirement tracing, so you can test the design. You can trace the design to the source and to the tests. That's all included in Ankaios. We can handle multiple nodes and VMs with a single API. And yeah, then also when it comes to communication in the cloud native world, usually you have IP-based protocols with the REST API. Ankaios supports that as well. But in automotive, you also have protocols like SumIP or DDS, and those can be used with Ankaios as well. And yeah, we also support Kubernetes pod resources. So if you know how to write a Kubernetes pod resource, then you can use that with Ankaios as well. And last but not least, it's also funded, partially funded by the Gaia X4 Ageda project, where we as Elektrobit participate together with other partners. And yeah, that was a course overview. Now I hand over to Kaloyan for all the technical details.
All right, thanks, Holger. So let me give you a short high-level overview of how Ankaios works. So to form the cluster, we first start Ankaios server, and then agents can connect to it. In the meantime, the server can actually read a startup configuration file, which is then pushed down to the according agent that should run the application. What we've summarized here are 3 main use cases that we wanted to show now. So of course, the simplest one is starting a normal application here as an OCI container, just as an example. But we also would like to support other use cases. For example, if we have apps that have dependencies between each other. So let's imagine we have a health manager that actually depends on a security application. And these two are also running in as different applications. So the one is an OCI containerized application, and the other one is a native application, just as an example. And they're also running on different nodes, are managed by different agents. We want that Ankaios actually checks these dependencies and then first start the security application and only afterwards the health manager. Another use case that we would like to support is starting applications by other applications. So in the example with the health manager here, if we see at some point that the health manager now detects that another application must be started, we would like to give the opportunity here to the applications to directly talk with the cluster and instruct it to start another application. Not only this, actually, it can also read states, update, and so on, but just as an example here. And then the expectation is that once the health manager instructs the cluster to start the others application, it's being started then afterwards by the correct agent. From a deployment point of view, this is just an example here. We have in the vehicle 2 HPCs. And on one of them, we also have a hypervisor running with 2 virtual machines. You can run Ankaios wherever you want. In the example here, we have the server and the agent running on one virtual machine, and then 2 agents, one running on a physical machine and one on a virtual machine. So just as an example. We also have separated the executables of the server and the agent with the idea that we are flexible here and you can theoretically just run only the server in one machine to get it separated out of the rest. Regarding a high-level architecture overview, well, as you can imagine, the server and the agent are running, of course, in the vehicle, where we have one server and multiple agents connected to a cluster. And then the Ankaios agent actually would have then runtime adapter per runtime type. We would like to support multiple runtimes via these adapters. And through this runtime adapter, we can communicate with the runtime engine or the runtime itself, and we can then manage workloads, applications, in the sense of we can start, update them, read out the states, and so on and so on. What we also have here is a control interface. So this is the backwards connection, so to speak, with which applications can then talk with the cluster, as mentioned on the previous slides. The idea here is that you can either read out states or change the state of the cluster. And using this, we can actually build stuff like cloud connector applications or workloads, which can then manage or help managing a fleet of vehicles. So the cloud connector would connect to a backend service, either in the cloud or on premise, depending on what the customers would like to have. And it can then either just monitor the state or instruct the cluster to install updates, things like this. From a development point of view, we are also providing a command line interface called Ank. This can run outside the vehicle or also in the vehicle, doesn't matter. So developers can, during the development phase, debug or monitor the state, and they can also, of course, connect, if provided the right privileges, also in production with cars. All right. To get the full picture, just to mention it here, so we are actually independent of the init system. We can be started by any init system. We don't care about it. And from a persistency point of view, we are assuming that the OEMs provide something in that direction so that you don't break the flash in the ECU. So the idea here is that these things are outside of Ankaios scope and we can just integrate with them. All right, and now for a demo of how the whole thing works. Hope I can start it here.
Before we actually deep dive into the demo, let me just show you what we
No,
have in
not
the demo
really.
folder here. There are 4 files. The first 3 are the
Oh, I think the
executables.
demos itself is
First one being
really.
the Ankaios command line
Sorry.
interface. The next two are the Ankaios agent.
No,
and
the clicker
server.
doesn't work.
And the fourth file is the Ankaios config.
But I think the sound is not
Inside
there.
the config, the root element workload specifies 3 workloads that are to be executed.
Excuse me.
First one
So we
being the
tested
cluster
it before, and there the sound worked.
which should be executed by the Podman runtime
Now it's working.
on the
But I should.
HPC1
Can we now
Can you go back?
go back? Yeah, sorry. Well, we recorded it not to get into technical trouble, but we are in technical trouble now with the
Before we
recording. So
actually dive into the demo, let me just show you what we have in the demo folder here. There are 4 files. The first 3 are the executables that we need. First one being the Ankaios command line interface. The next 2 are the Ankaios agent and server. And the fourth file is the Ankaios config. Let's peek inside the config. The root element workload specifies 3 workloads that are to be executed. First one being the cluster instrument, which should be executed by the Podman runtime on the HPC1 agent. I'm not going to go into a lot of detail here about the configuration. What's interesting is the runtime config, which specifies that this workload should run the cluster instrument OCI container in a version 0.1. The next 2 workloads just simulate some vehicle system checks, a battery check, and a brake system check. They just finish up their work and successfully go out. So let's now start our server with the config. Worth mentioning here, the server is per default listening on a port on the local host with IPv4, but we also support the newer version, IPv6, so it can also be used. When we start the server, it detects that there are 3 workloads to be started on 2 different agents, HPC1 and HPC2. The warning messages that you see are because we have not yet started the agents. So let's do this. Say here Ankaios agent. So let's start first HPC2. This was the one with the 2 system checks. When we started, we see the server received a hello from it. It sent the workload configurations to the agent. The agents then started the 2 workloads. They were initially in exec running state. They finished up their work and went into exec succeeded state then afterwards. Let's start the other agent, HPC1. This was the one that starts the workload with the cluster instrument simulation. So if we start this one, we additionally to the config here for the workload being executed, get some other messages from the Ankaios server, which are giving us some information here about workload states of other workloads on different agents. This is something that we need for the dependency management that we are going to implement later. For now, what's interesting is that the cluster instrument workload is now in an exec running state. And let's take a look at it. So we see our nice cluster instrument here. But let's imagine now that we want to make an update of the application. If this is done the old way, we should now actually flash the whole target to make the changes. But since we're using a container and this is orchestrated, the task is getting a little bit easier here. So let's now play a bit with the Ankaios command line interface. So these are the commands that we're currently supporting. There is a get and a set command. So let's say now Ank get help. We are supporting here either the complete state, which is stored inside the Ankaios cluster, or we can get some convenience information on the workloads themselves. So let's execute this one, get workloads, and we see here our 3 workloads. 2 are in execution state succeeded, and the cluster instrument is still running, which is also our expectation. If we want now to make the update, we can get the complete state, write it into a new file, then open the file and make some changes to the configuration that we just saw. So here's the configuration of the cluster instrument workload. So what we just need to do is update the version here. Save the file. Now we can call the Ankaios command line with the set command and instruct it to actually set the state of the cluster to a new one. And what we especially want to set here is we want to update only the cluster instrument workload with what we just saw. In the background here, we see that the agent responsible for this cluster instrument workload actually detected the update, it deleted the old workload, and created a new one on its place. If we go now to our cluster instrument simulation, we see now that the update has taken place. We now have more punchier colors here at the screen.
All right, so that was it for the demo.
Before we actually,
So we are happy to answer some questions.
Do you have any questions?
Hi. So my question is, so you provide a container runtime, basically container management for different runtimes and also execute native applications. So how do you communicate between applications within a container and a native application? And second, what was the need to have still native applications running?
Well, maybe the second one is easier, so let me start with this one. It's performance. Containers take some time to start, and in automotive, it's very important that you have a very quick startup time. So if you unlock your car, you don't want to wait for 10 seconds until everything's booted so that you can start your engine, right? So until we get to a point where containers do start as fast as just a native application, sometimes we see the need that we have to start some things as a native application so that we get the performance which is needed inside automotive.
And I think another reason might be when it comes to functional safety, currently Ankaios is designed for QM. But I mean, there are some thoughts how it might be extended, and then native applications also might play an important role on that one.
So that you don't have to actually have the complete chain with the container runtime and everything functional safety certified. But for native applications, it would be easier then.
But I think another part of your question was how does the communication work between the application and Ankaios? And we decided to use pipes for that. Other systems like Kubernetes have another way, and we thought about different options. For example, having a gRPC interface between the application and Ankaios. But finally, we decided for pipes because they're available on a lot of systems, and the most important reason for that was that we can use the authentication mechanism that is already built in Linux because pipes are just files, and we can control the access with that one. Otherwise, when you look at Kubernetes, you have to provide credentials to every single application so that they can authenticate. And we have a much easier way, but still as safe as other systems, as secure as other systems.
Yeah, so a couple of questions online. How different is it from Kanto? Are you familiar with Eclipse Kanto? And
Yeah, we looked at Kanto, and we think Kanto has a different scope. I mean, it's mostly for IoT systems as well. It's written in Go, and so we decided for different way. We wanted to have the Unix approach. I mean, Kanto does a lot of things, and Ankaios is especially focused on container and workload orchestration. So we want to follow the Unix approach, the Linux approach, do one thing and do that thing good. So, I mean, there are a lot of things outside, like, for example, container runtime. We don't write another container runtime. We have one thing that does the management. We want to do that very good. And we decided to have a separate application like Ankaios. We've written it in Rust and especially designed for automotive, especially for that use case. I think that's the main difference.
And if you want more features, you can still do it using this control interface that we just showed. So you can just write your own workload, which can read or change the state of the cluster. And via this, you can then achieve some other features that are needed.
Please.
On this one block chart, you had everything built up on this EB Corpus Linux. Is the software built on top of that? So does it require the specific Linux, or is it just as an example?
It's just an example.
You can use any Linux you like.
Okay, thank you.
Currently, we require Linux, but you're up to use your favorite distribution, of course.
We also don't require a lot from the things that Linux actually provides. So it could be some POSIX compatibility even without the complete full-blown Linux there.
Thank you.
Yeah, another question online goes towards your roadmap. And the question is from Steve, when are we going to see some code? Because there's a lot of synergies, not only with other projects, I might add, but also with one of our breakout groups, which was about the software orchestration.
Yeah, I mean, I've seen in the demo, we are already pretty far. So the basic things are running. We are currently need to do the final cleanup, creating the documentation. So we plan to have the initial contribution till end of September. That's the current plan. So yeah, we want to have a good experience when we have the first contribution, but we are pretty close. I mean, we need to do some cleanup. Currently creating the website with the documentation, having a getting started guide, describe the installation procedure and things like that. That's still missing, but the main code base is there. And yeah, stay tuned, and hopefully till end of September you can see something.
Great. Good. We might have time for one more question. If there is any, yeah, over there. Just like against the light, I see. I'm gonna check online if there are others.
So what are the challenges you see in using these Ankaios for ASIL applications?
I think I didn't get that.
Sorry, me too. Can you just repeat it?
You meant that this container-based applications or approach is being targeted only for QM, right? For the moment, QM app.
Yes, for
right?
For QM, yes, exactly. Yes, for now.
But you said you will also be moving it to ASIL-based applications, right? Or you don't have that in your roadmap?
Well, I mean, when it comes to safety, that's when you look at the software stack. I mean, when you want to have safety applications, there are a lot of components involved. It's not only Ankaios itself, but you have the hypervisor, you have the Linux. What's missing on this picture, of course, is the container runtime and things like that. So there are a lot of components involved. And for safety, probably we need a more slim approach. That's why we started with Ankaios first with the QM approach. And we have to see how that can be tailored, adapted then maybe later on for safety workloads. But I think that's the different story for the time being. As you showed, the example we have was with infotainment system. I think that's a good use case for that one. And